When we come to the Rutherford experiment, because we are now characterizing an atom, if we know the electron, the subatom electron, if we know another subatom, by having different experiments, the first one has already been mentioned, the electron using cathode ray tube, and the other is gold foil experiment. In gold foil experiment, this is gold foil experiment, and in gold foil experiment we have alpha particles. As you know, alpha particle it is 4 times heavier than hydrogen. So these streaming particles bombard the gold foil experiment. In this gold foil experiment, Rutherford was very excited when he see the experimental outcome. And what was the experimental outcome? He bombarded alpha particle into the gold foil, and he has observed bouncing back of the alpha particles at a certain point, and the rest pass without any problem. So in this experiment, he was very fascinated, because how come a very strong alpha particle bounce back from a thin foil of gold? So he was able to conclude certain points, and the first part is there is something strong at the center, or massive bundle. There is a massive bundle of something in at the center, bundle. And he said that most part of an atom is empty, because he didn't see any bounce back. And this massive bundle is found at the center. There is a central point. At the central point, there is a massive stuff. So from this time on, we have a term called nuclear model, because the nuclear is because of a nucleus. So if you see this massive part as compared to the other parts, if we are going to see this clearly in this picture, the beam of particle is sent to the atom, and in some parts where there is no dense part, the streaming particles easily pass through. But at certain point, as you can see here, there is a deflection, bouncing back. This bouncing back has given something very important interpretation. This is the point where he says this bouncing back is because there is a heavy or massive bundle of something at the center. So as you can see, except the central part, all of the streaming particles, or the alpha particles, pass through the atom. So the deflection is observed at certain small area. So that dense part was called a nucleus. And another part, conclusion by him, the nucleus is positively charged. The nucleus is positively charged. Why he said positively charged? Because this streaming particle bounce back, because alpha particle, which is alpha particle, is positive charge, and this bouncing is done because the nucleus must have been a positive charge. That's why this bouncing happened. Uh, as you can see in the picture, this bouncing is made. So let's see this very easily. In the previous discussion, we have a plum pudding model of Thompson. He made a model. This model indicates that a negatively charged particle scattered all over the surface of the atom. And he expected that, Rutherford expected, if the model of Thomson is right, he expected that all the particles can easily pass and will be observed here. But this didn't happen in the case of the gold foil experiment. As you can see, this area, nothing passes through this area, which means the bouncing is at the center. Other parts, look, if you see this part and this part, the streaming part, the alpha particle can easily penetrate in this area. So according to his experiment, he was able to say there is a dense part at the center. Here it is nucleus. And most part of an atom is empty space. That's why the alpha particle can easily penetrate. And the other part, this heavy part, because of the bouncing back, it is positively charged. That's why we have a nuclear atom. This nuclear atom concept is obtained from Rutherford's model of an atom. So Thomson's model is completely now discarded as the result of gold foil experiment. So this is not the real representation of an atom. Next, we are going to see how the electron, role of electrons, because Rutherford has said nothing about the electron. So in Niels Bohr experiment, we are going to see the experiment. So according to this one, we have the Thomson's model. So alpha particles are not getting obstruction everywhere. You can see here. So the plum pudding atom indicates that no, the positive and negative charges of an atom, which is the electron, are not distributed in a way Thomson suggested. This one is a very better approach, or it has given good insight about the nature of atoms in general. So some of the statements given by the Rutherford is still a powerful statements. So we are going to see in the next slide again